Hello, everyone. In chapter 8, we learned how to calculate the weighted average cost of capital. That is a discount rate. Basically, that's a discount rate for the project. And also, we learned the cash flow from assets. That's the cash flows for the project. And then after we have the projection of both discount rate and the cash flows, then we need to make the decision based on those data, like should we accept the project or reject the project. And those criteria called investment criteria. In this video, I will introduce the most important and basic criteria called the net present value method. Next video, I will introduce another type of investment criteria called internal rate of return. That is here, IRR, internal rate of return. And that is in chapter 11, class 1. So again, for capital budgeting, basically, we do the analysis of potential discount rate and do the analysis based on the cash flows, possible future cash flows of the project. And then we make decisions about whether or not should we accept the project based on whether the project will add benefit to the shareholders' welfare, or this project has a potential addition to the fixed assets. The step for capital budgeting: first, estimate cash inflows and cash outflows. So this is estimate the cash flow from the assets for project, and then assess the riskiness of cash flows. So basically, that is used to those two together. The riskiness of cash flow is also linked to determine the cost of capital for the cash flows of this project. The higher risk means higher return. We need to use higher discount rate. Lower risk means lower return. Then we need to use a lower discount rate. And then we can use those two major investment criteria, net present value and the internal rate of return, to determine whether we should accept or reject the project. The criteria: if the net present value is greater than 0, we accept it. If the internal rate of return is greater than this weighted average cost of capital is the cost of capital here, then we accept it. But we will talk about that later in more details. And before we talk about the investment decisions, we need to know there's two types of decisions. First is decision related to independent projects. So basically, there's just one project. We determine whether we should accept it or reject it. And the second type of decision is called a mutually exclusive project. So there's a set of projects, and you can only choose one. And those are two types of decision, and the decision we made should be based on whether it's an independent project or it's a set of mutually exclusive projects. So what is a mutually exclusive project? Here is one example. A firm owns some land worth 25 million, and the firm has 3 options: sell the land, or build a factory on the land, or build a commercial building on the land. You can either sell the land or build something on the land. And when you build something on the land, you have to choose either you build a factory on the land or you build a commercial buildings on the land. You cannot do both. So this is mutually exclusive projects. You have to choose one out of all those options. So, okay, so let's focus on NPV first. NPV, the full name is net present value. It's the sum of the present value of all cash inflows and cash outflows of the project. And then we can measure whether it's the net present value after we deduct the present value of cost, whether I get a positive number or a negative number. The rule is that when NPV is positive, means that the shareholders' welfare is increased. So a positive NPV means the project is expected to add value to the firm and increase the wealth of the owners. Since our goal, remember our goal is to increase the price, maximize the price of existing shareholders' stocks. And because NPV, positive NPV project actually add value to the firms. So NPV is actually a direct measure of how well this firm will meet our goals. NPV is the present value of all cash inflows minus the present value of the cash outflows. It's a net gain in wealth. And we assume that the cash flows are reinvested at a weighted average cost of capital because the discount rate is weighted average cost of capital. So the net present value, so we discount all the cash flows from t equal to 0 to the end of the project by this R. R here is weighted average cost of capital. And here is one example of NPV rules application. So we have two projects. The first project is called, we label it as L. So the initial investment is -100. And the first year, for the L project, we will receive $10, second year $60, third year $80. And comparably, we have another project, it's called S. This S project also need a $100 initial investment. And then it will receive 3 cash flows over the next 3 years. $70, $50, and $20 respectively. Here we also provided the difference between those two cash flows. So this delta CF is the difference between cash flow of project L and the cash flow of project S. Here we will talk about the difference, how could we use, why we need this delta CF here. Later, but we should know is 0 is equal to -100 minus -100 is 0. 10 minus 70 is -60. 60 minus 50 is 10, and 18 minus 20 is 60. And how to calculate the NPV of project L? We of course can use the formula here, this formula here. However, we have a more straightforward way to use the financial calculators. You're quite familiar with that, but I will still show you how to use it in the financial calculator. So the financial calculator, remember for project L, the initial investment is -100. So we pass this cash flow here. And the initial investment is -100, and then press enter, and it goes down. Cash flow, the first cash flow is 10. Enter, we only has one $10. The second cash flow is 60. And the third cash flow is 80. We leave this F as 1 for all 3 cash flows because we only have one 10, 1, 61, 80 respectively. And after that, we press NPV, and the interest rate is 10, it's not 0.1, it's 10, we ignore those percentage sign and enter, goes down, compute. So that is the NPV of project L. It's 18.78. The NPV of project S, that's calculated. So NPV of L looks like this. Then I go back to cash flow and press second and CEC. I clear all the previous work. So CF0, that's the initial investment for project S, is negative 100. CF1 is 70. CF2 is 50. CF3 is 20. Enter. And press NPV. Interest rate is 10 again. And NPV for project S is 19.98. So the NPV in our slides is the discount rate is over here. Just try to remind it. So if the projects are independent, because both NPV are positive, we accept if the NPV is positive. So we accept both. If the projects are mutually exclusive, we will accept the project with highest NPV. Because the highest NPV project adds the most value to the firm. So in the example, we accept S if this is a mutually exclusive project, because S has higher NPV than L, and accept both if they are independent. And the next thing I would like to introduce is this so-called NPV profile. NPV profile is like we calculate NPV under different scenarios of weighted average cost of capital, or we see under different discount rate, what's the NPV for the project. So I listed here NPV of S when the weighted average cost of capital is 0%, 5%, 10%, 15%, 20%, and 25%. How could we calculate this in our financial calculator? What we will do is like we just go up and change I into 0. And go down and press compute. That is 40. We write it down, go up. Interest rate is 5%. Press enter and go down, compute. So when the discount rate is 5%, NPV is 29.29%. If the interest rate is 10%, as we know, the NPV is 19.98%. If the interest rate is 15%, NPV is 11.83%. If the interest rate weighted average cost of capital is 20%, NPV is 4.63%. If NPV is 25%, then the NPV changes to negative. If the project is super risky, the weighted average cost of capital is 25%, then the NPV turns to negative. The firm should reject it, right? And then how about the project S? We go back to the cash flows and clear all the previous work. And for project S, the initial investment is negative 100. And then we press enter, goes down. The first cash flow for project L is 10. The second is 60. The third is 80. And then we press NPV. If the interest rate is 0, NPV is 50. Goes up again, interest rate is 5. NPV is 33.05. If interest rate is 10, we already know that. The NPV is 18.78. If the interest rate is 15, then NPV is 6.67. If NPV is 20, NPV changes to negative. And if the interest rate is 25, NPV becomes even more negative. So that is NPV, how to construct the NPV profile. And we copy those numbers down. That is the NPV profile for project L. And then we can plot it, use a figure. And we found that there's a crossover point here. So basically, this is so this orange line is NPVS. This is NPV of S, and this blue line is NPV of L. And when the weighted average cost of capital, the horizontal line axis is weighted average cost of capital. When the horizontal weighted average cost of capital is less than the crossover point, so NPVL is greater than NPVS. If the weighted average cost of capital is greater than the crossover point, then NPVS is greater than NPVL. So we can see this original line is greater than the blue line. So here's one more project practice for NPV. Is that the initial cost is -30, and then that's the cash inflow, cash outflows. So net cash flows is 6 or from year 1 to year 8. The salvage value is $2, so net cash flow is for t equal to 0 is -30, and from year 1 to year 7 is 6. For year 8 is 8. And the weighted average cost of capital is 15%. So find the NPV of the project. So if we draw a timeline, this is data 0, 1 to 6, 7, 8. The interest rate is 15%. T equal to 0, the initial cost, which is CF0, is -30. From year 1 to year 7, the cash flow is 6, and year 8, the cash flow is 8. So CF0, CO1, the first set of cash flow is 6. And in total, we have 7, 1, 2, 3, 4, 6, 7, 1, 2, 3, 4, 5, 6, 7. We have 7, 6 in sequence. So FO1 is 7. And the second cash flow sequence is 8, and we only have 1, 8. And then we can find out the NPV here. So I will use financial calculator to calculate it again. So again, we press CF and clear all the previous work. CF0 is -30. CO1 is 6. So this is the first cash flow sequence. There's a 7, 6, one by one, one followed by another. And the second series of cash flow is $8. We only have one $8, so we leave FO2 as 1. And then we press NPV, the interest rate is 15, and we calculate the NPV here. So here is a summary of NPV rules. Does NPV rules account for the time value of money? Yes, because we discount all the cash flow to today's value. Does NPV rules account for the risk of the cash flows? Yes, because we discounted by weighted average cost of capital, and this weighted average cost of capital measures the risk of the project. Does NPV rules provide an indication of increase in value? Yes. Positive NPV means there's an increase in value. Should we consider NPV rules for our primary decision criteria? Yes. This is the most and the most important and basic rules. Okay, that is NPV here. So next video I will talk IRR, internal rate of return. Thank you for watching.